Hi, I am here. This is Dr. Klopfenstein to give you a short little video tutorial on how to use Praat to get those acoustic numbers for your final voice project. Just to give you a visual aid to help as you're trying to follow those written instructions. So here I have two files that are not the same as I've assigned, but they're examples of a prolonged ah and a connected speech sample. And I've just saved them here on my desktop so that they're easy to find. So the first thing I want to do is open up Praat, and I'll move this over. Actually, we don't need this window at all so that you can better see what I'm doing. So first thing I want to do is open those files, and I'll go to open and then read from file. Be careful not to choose this next option, open long sound file, since that might make some of these analyses not possible. So be sure to use that first option, read from file. And then I'll go to my desktop, scroll down here, or up, till I find, there they are, those two files, and I can actually open them at the same time by holding Control and then clicking both of those files. Okay, I have them both selected, so then I can go ahead and select Open here to put them both here in my Objects window. Now I'm going to start with the prolonged vowel first, and the first thing you want to do is use View and Edit and take a look at what you're doing, since there might be other things going on in the sound file that you might not want to include. So let's listen to this one. All right, so if you can hear that in the background, this particular sound file has a speaker that's not able to prolong the ah very long. So we have little bits of ah here, and we just want to select one to look at. So maybe we'll try this one in the middle here and see how that works out for analysis. So I want to highlight that portion and then hit the select button here at the lower left corner. All right, and that gives us an ah here that we can play again to listen and make sure it's what we want. And although he's got a voice break here in the middle, maybe we should include that if this is typical of his productions. So if I go here and go up to this top menu here, I have this whole selection here selected because it's highlighted in pink here. It may be a different color on your computer. But usually when you select a portion of the sound file, it'll be highlighted some color. And since I just want to look at this part, not the whole thing, I can go to File and then Extract Selected Sound. And you want to choose this second option here where it says Time from 0. And that just means that we're just going to cut out this little chunk and start here at the beginning of that sound from 0. Not that we're going to preserve any time information from the original file. There's no need for that in this case. All right, so then I can close this window, and there'll be a new sound here in my object window that says Sound Untitled. I could always give it a new name. I could click Rename there at the bottom and call this, for example, something like Trimmed just so that you don't get confused as new objects get added here. So we'll give it a name. And then if we do View and Edit, it should look just like that selection we had before. So if I click here to play this total duration of the sound, it should be just the same as what we had before. So now it's ready to analyze. So one of the first things we want to do, I've sort of set up a little thing here where these are all the things I'm asking you for in terms of numbers. And we can start filling in the numbers here for the sustained vowels portion. So I'm going to go here back to our object window, and I have the sound selected, and I'm going to go to analyze periodicity to get some of that pitch information. So first I'm going to create a pitch object by clicking on that button, analyze periodicity, and then going to the option to pitch, the first one. And this little dialog comes up, and for any of your cases, there's no reason to change any of these numbers. They should work just fine. And then you can just click OK. All right, and then everything sort of jumps away for a second, but you'll see if you go back to your object window that there is a new object called pitch trimmed ah. And if I view and edit it, it looks like this. And all it does is it gives you something that you could manipulate if you wanted to, let's say, change the pitch and then add it back to the sound. And it sounds something like this if you click one of these lower buttons, where it's just Praat is reproducing a synthesized version of this person's pitch. And you can see this little portion here where Praat couldn't analyze the pitch is still there in the middle. Let's say you had something incorrect where maybe there's one of these little sort of pinkish looking dots is up, and it's somewhere up here in the 500 or 400 range, and that doesn't sound right for what your client is doing. You could always just select that portion to eliminate it from analysis, and go here to selection and unvoice, and then it's gone. But we don't really need to do that. We'll undo those last two. Actually, it won't let me redo both of them, so we'll just redo the unvoice so that little extra thing I added there isn't included. All right, so next we can just go to query, and there's some extra pitch info that we can get just by going to pitch info and looking at this box that comes up. So one of the things I'm asking you for is pitch sigma, or standard deviation. When you talk about pitch sigma, usually you're assuming you're talking about semitones, which is given here. But you could also report the standard deviation in hertz, which is what I've just highlighted here. There are other types of measurements for the standard deviation. Here's one in MEL and ERB, but we haven't talked about those, so you can ignore those for now. So I am going to report it in semitones here. So what the information I want is 1.24 semitones. So if I go to this little box I've set up here, I would want to write here that I have 1.24 semitones. All right, and the other thing we could do is look at the average fundamental frequency that I've highlighted here. That information is also reported in this window if you go here and look at this average section. And Praat gives you several different ways to report it, but for our purposes, it's more helpful to have the average given in hertz. So this first option is the most useful number for our purposes. So 169 point something something hertz is what we'd want to do. So I can just take that little bit of information and paste it right here in my document. All right, that doesn't cover everything you'll need to do for your sustained vowel. So we also need jitter, shimmer, and HNR, which isn't included in that little window here. So we'll close that and this pitch object and go back to these objects here to get that information. So the first thing we want to do is go back to our original trimmed sound file and create a new pitch object. So we're going to go to Analyze Periodicity and then to pitch CC. This is important. It's a different way of calculating that pitch object, and we're going to need that. So choose that option. It's slightly different than what we had before. And it's okay to say okay to all these numbers. All right, and again, the window sort of pops away, so you have to go back to your Praat object and find it again. Okay, and then what you have to do next is using the control key, or whatever the equivalent is on a Mac, is if you hold on that key and click two of these objects at the same time, you will get a different menu here to the right. And we want to do that so that we get this button here that says 2-point process CC. And that's what you're going to click next. And then it's going to create something else here. And that new object is called point process, and then it's going to have this new name here. And the last thing we're going to want to do is select this sound, the second pitch object we created, and that point process all at the same time. So you're going to have to use that control key again, or whatever you have on the Mac, to help you select more than one object at one time. And then you see, once you have all those objects highlighted, that again over here to the right, the options change, and you have a new button here for a voice report, and that's exactly what we want. You can go ahead and click on that button, and it'll have some options, which those are all good for your purposes, and so we can go ahead and click OK. And then we have this new info box that will open with all sorts of new information. So you can take this and actually collect a few numbers here, not just, you'll see you have jitter, shimmer, and harmonicity, or our harmonics to noise information, but you also could get your average and your standard deviation here, but unfortunately the standard deviation is only given in hertz. So that's why I go ahead and have you do it that other way. But in terms of numbers we want for our for your voice report would be just those certain options here under jitter. You'll see there's lots of different ways to calculate jitter, but in order to make sure that you're comparing it to the right type of norms, like the ones I gave you, you want to use these options here that just have local in parentheses after the name in terms of jitter and shimmer. Here, so it's always going to be the first option for each of these types of measurements. So we're going to select here, the jitter is 1.069%, and you can simply copy that and paste it here into wherever you started your report. So there is your jitter, and here is the shimmer number we want to use, just the one that has local in parentheses after the name shimmer. So it's 4.088%. I'm just going to copy and then paste it here into my Word document. And the last number I want is H&R, or harmonics to noise. So I want to take this number here. The other one that you have the option of using, or one of the other ones, is noise to harmonics ratio, which is just the inverse, but I haven't given you norms for that. So this number is most helpful, the 19 point whatever dB. So I'm going to copy and then paste it here into my Word document. All right, so that finishes off everything for the sustained vowel, and all we are left with are things that we need from our connected speech sample. So I'm going to close this info box, I don't need that anymore, and go back to the object window here and go to my connected speech sample. And it's always a good idea again to do view and edit and select some portion of the connected speech sample that you think best represents the client's speech. Since there may be more, there may be the clinician talking in the background, or other things that might cause you not to want to use a particular speech sample. Let's say, for example, this looks like a little blurb of speech. If I listen to that, it sounds like that's the patient, judging by the quality of the speech. And that actually sounds like a good place to go. So I'm going to just go ahead and select that for sake of not taking too much time here, and take a closer look and use that for my analysis. You'll want to spend a little bit more time examining each part of your connected speech sample. And here, judging by this one, there's a few things that might be a little bit off here. And I'm going to crank up the volume a little bit so we can hopefully hear that on your end. All right, so he's talking about the cookie theft picture. You'll have that a lot in your speech samples, likely, since they were all taken the same way. And it looks like here there might be areas where, judging by his voice, he's not having dramatic pitch breaks like Praat's pitch contour seems to indicate where I've circled. And there's also this little blurb here that doesn't even seem to correspond with a voice section. But either you can include this or you can try and correct the pitch object, which is more complicated. My advice at this point, you can include these errors and just account for that in your report, and that would be good enough for me. It's going to be hard for Praat to calculate some of these values because of these voices are so disordered. This one is a particularly extreme example. Yours may not be this bad. But as long as you say, well, this might be elevated or that might be elevated based on what you saw, that is, just exactly what I'm looking for. That you can look at some of these values and determine whether they are reliable or not based on your knowledge of speech science and voice disorders. Okay, so I'm going to erase that. And we're going to go ahead and use this section of speech, despite those problems I mentioned before. So I'm going to highlight where the speech is, and I'm going to trim that then from the larger sound file. So again, you can go to File and extract selected sound with the time from 0. And if we close this, we'll see there's a new sound here. And this is what we're going to use. And if we click View and Edit, it should correspond to what we just had earlier. All right, so we have the pitch contour. Those are those blue lines here throughout the speech. That's good, but we're also going to want some intensity information. So if you don't have a yellow line in this sample, you want to go to Intensity and select Show Intensity. And then you'll see a yellow line pop up on the spectrogram. If you don't have the pitch contour, you can go to Pitch and then make sure that Show Pitch is selected. And then you should have that blue line on there as well. Now that the intensity contour is showing, we can ask Praat for that average intensity that I asked you for, the mean speaking intensity of conversational speech that you can use to make judgments about whether this person is speaking appropriately loudly, that they're loud enough to be understood. So if you go to Intensity and select Get Intensity, or you'll see there's a shortcut option here at the very right. Hit your F8 button. Either way, if you do that, you will get this little info box popping up. And you can take that value and cut and paste it into your report. So here his average intensity is about 64 dB. So I'm just going to copy that number and paste it into my document here. All right, other than that, I have a range that I want to know from his lowest fundamental frequency in hertz to his highest. and the pitch sigma or standard deviation, and the average fundamental frequency. All that frequency information is left. So I can get that all if I exit out of this sound. There's a lot of different ways you could get this info, but the easiest would be just to create another pitch object and get all that information from that pitch info option. So to do that, I'm going to make sure the sound is highlighted in the Praat object window and go to the Analyze Periodicity button again. When you click that, you get this menu dropping down and you'll want to select to pitch. Hit OK, and then if we go back to the object window, we'll see we have a new pitch object. You can hit view and edit on that and go up to the query window, and here you can either highlight those portions that are unreliable and go to selection and unvoice, and they won't be included in the measurement, or you can keep them in and account for that in your final numbers. So if I go to query and pitch info, I'll get a new info box that will give me all this information that I need. So let's start with the average. Here where his average pitch throughout the whole thing is 181 and something hertz. So I'm going to copy that number and add it in here for his connected speech sample. All right, and I'm going to look at his standard deviation, and I'm going to use the value in semitones since this is a little bit easier to interpret. If we just report it in hertz, it's hard to know how much an impact that has on our perception without converting it to semitones. So we're going to choose that value instead, copy it, and paste it here into the document. And the last number I need here is the range. And if you use this info, you won't even need to calculate that. You can use this column of or line of information here, and this time I explicitly ask for it in hertz, so that way if you have the average in hertz, you can compare that to the range. It's just sort of useful background info to have. Highlight that, copy, and paste it into the document here. All right, so I hope that helps just with getting the numbers. If you need any help interpreting these numbers or run into problems on the way, I'm always more than happy to help you, and it's usually easier in person. All right, so I hope you found this easy to follow, and just let me know if you have any further questions.